Hello students, how are you all? I hope everyone fine. So in last class we learned the basic concepts of vector, that is definition of vector and types of vector. Today we will take a very important section of vector. Okay, maybe this concept you studied in physics in first PUC, repetition and some extra work is there in mathematical format. So remember, most of the things are repeated. Okay, repetition today because this is done already in first PUC physics. Okay, so kasta agala, observe mani correct agi. Yeah, today we are going to learn the addition of two vectors, scalar multiplication of two vectors, representation of a vector in a plane, two-dimensional, three-dimensional. After that, scalar product, vector product, scalar triple product. Idella nenpide alva because iದೇ concept ನೀವು physics ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ. So ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದೆ ಅಷ್ಟೇ compared to physics. Okay, so as I told, today's first topic, additions of two vectors. How to add two vectors? ನೆನಪಿದೆಯಾ? Triangular law of addition, parallelogram law of addition ನೆನಪಿದೆಯಲ್ವಾ? because in triangular law of addition physics ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರ್ತೀರಿ, so ಅದನ್ನೇ explain ಮಾಡ್ತಿದ್ದೇನೆ, observe ಮಾಡಿ. Okay, so the first topic under the heading addition of two vector is triangular law of addition. Okay, observe carefully. Consider two vectors, vector AB and vector BC, so that okay this point is common for both. ನೆನಪಲ್ಲಿ okay, ಇದನ್ನ vector A. See, last class ಅಲ್ಲಿ I told to represent vector AB as any vector as a vector AB, where initial point is A, terminal point is B. You can represent this vector as another format, vector A. ಇದರ ಮೀನಿಂಗ್ ಏನು? ಹೀಗೆ ಬರೆದ್ರೆ the magnitude of vector AB is A. If the magnitude of vector AB is A, then vector AB can be represented as single letter vector A. But ನೆನಪಲ್ಲಿ two small letter you cannot use to represent a vector, and single capital letter you cannot use to represent a vector. ಎರಡು allow ಇಲ್ಲ, ಈ ಎರಡು representation allow ಇಲ್ಲ. But a vector AB can be represented using single letter like this, and it should be a small letter always. Okay, capital letter use ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ initial point, terminal point mention ಮಾಡಲೇಬೇಕು. Single letter use ಮಾಡಿದ್ರೆ you are using the magnitude of the vector. So if I take vector AB as vector A, then remember magnitude of vector AB is A. Okay, then purely concept ಗೊತ್ತಿದೆ, physics ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದಿರಿ, but still I am reminding you. So similarly, if I take vector BC as a B, then remember magnitude of vector BC is B. Correct ಆಗಿ ನೆನಪಿರಲಿ. Then this law says that if these two are the vector representing a triangle, the third side, the largest side, okay, always represent the sum of two vectors. So this side always represents sum of two vectors, that is vector AC represent vector A plus vector B, and this expression is called triangular law of addition. Vector AC is equal to vector AB plus vector BC. ಇಲ್ಲಿ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಕರೆಕ್ಟ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. Observe the direction of vector AB and vector BC. Same direction alva? Direction of vector AB and vector BC is same, but the sum of two vector is always opposite to other two direction. ಇದು opposite alva? The sum of two vectors always represent, direction of sum of two vector is always opposite to that of given vector. So vector AC direction is always opposite to vector A and vector B, and this is known as triangular law of addition. Triangular law of addition. Define triangular law of addition ಅಂತ ಎಕ್ಸಾಂಪಲ್ ಡೆಫಿನೆಟ್ ಆಗಿ ಬರೋದಿಲ್ಲ, ಬಟ್ ಅದು ಏನಂತ ಗೊತ್ತಿರಬೇಕು. ಸೊ ಇನ್ನು ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ಅರ್ಥ ಆಗಬೇಕಾದ್ರೆ I'll take some examples. You try to understand what do you mean by triangular law of addition. Observe carefully. Yeah, so I'll try to one triangle. I'll take one triangle, I'll write the directions, you have to tell me what is the triangular law of addition. So vector A, B, C. Okay, I'll give the direction like this. Can you tell me what is the triangular law of addition to this triangle? Pick the two same sided vector. Yaudala same direction vector, vector AB and vector BC are same direction vector alva? See, direction is same on their direction. Which is opposite side vector, opposite direction vector, vector AC. See, done. Triangle, no need should be like this only always. Don't think that it should be always obtuse angle triangle. ಯಾವ type of triangle you go, triangle law of addition apply ಮಾಡಬಹುದು. So remember, so vector AB, vector BC are in same direction, so the sum of these two vectors should be this vector, this side, vector AC. Okay, let me take one more example. This is example number 1. I'll take here example number 2. Suppose triangle is like this. Vector, this is vector A, this is vector B, this is vector C. Can you tell me what is the triangular law of addition to this triangle? Observe my diagram. Can you tell me what is the triangular law of addition? First, what I told, you have to pick the same direction vector. Vector A and vector C are the same direction vector. Alva? Same direction. Observe madi. Which is opposite direction? Vector B. So this is a triangular law of addition to the triangle. So I hope you understood. So pick the two same sided vector, and the third one, okay, which is opposite to that of two given vector, will be always representing sum of two vector, and this concept is known as triangular law of addition. And this law is used to add two vectors. Correcta? Clear aitalva? So istnen bitkoli statement enilla triangular law of addition ge, you just pick the two same sided vector, and the third side which is opposite to that of two vector is always represent sum, and that is known as triangular law of addition. Clear? Artha aitala, idu important concept nenpeni. Okay, now one more law of addition is there. It is called parallelogram law of addition. Okay, so I will explain that. Observe carefully, it's very important again. Okay, triangular law of addition ali minus and difference of two vectors and explain ಮಾಡಲಿಲ್ಲ. So but ಇದರಲ್ಲಿ difference of two vectors explain ಮಾಡಲಿಕ್ಕಾಗತ್ತೆ. Observe carefully. Consider parallelogram A, B, C and D. And in that parallelogram I am taking the length the AB as a vector A, andre the magnitude vector AB is A, and this side as a vector B. Then according to triangular law of addition, this side should be, vector A plus vector B. You know this, alva? Already I explained in the previous diagram or the previous concept. Okay, this is a one triangle. Okay, either to same direction vector in the opposite direction, so this side should represent A plus B. This is not parallelogram law of addition, this is a triangular law of addition. Now complete this triangle, convert this triangle into a parallelogram. I hope you can, or you know how to convert it. Then observe carefully, this side is parallel to this side because this is a property of parallelogram, so they are opposite and same in direction. So this side should be vector B, this side is vector A. Now observe carefully. Now for this triangle, I hope you can see that. Apply triangular law of addition. Okay, check whether you will get the same thing. Yeah, so same direction vector, when you add, you will get A plus B. Correct? On B plus A, what I'm going to discuss about that it is commutative. But observe carefully, if you apply triangle law of addition to this triangle, definitely you will get A plus B. So this is true. Triangle law of addition true, and in parallelogram, the triangular law of addition is true. Now observe carefully, I'll take another diagonal. This is the one diagonal, no? I'll take this diagonal. I'll give the direction to this diagonal like this. Now you have to refer this triangle. I hope you can, okay, you can see that triangle. Okay, now in this triangle, what is a triangle? In triangle ABD, apply triangular law of addition. Apply triangular law of addition. Tell me. In Bharat, apply triangular law of addition. In Bharat, see which are the two same direction vector. This, okay, this observe carefully. Idu opposite, alva? So idake yavadu parallel. So now observe this triangle, this direction, this and this same. So the same direction vectors are vector B plus vector A plus B. Sorry, vector B plus vector DB. A plus B is this triangle DB. Equal to, because these two are the same direction vector, and according to triangle law of addition, this sum must be equal to the side which is opposite to the remaining two, so that is vector A. So this implies vector DB is equal to vector A minus vector B, vector A minus vector B. So what we come to know that in a parallelogram, one diagonal represents sum, another diagonal represent the difference. One diagonal represents sum, another diagonal represent difference, and this is known as, okay, this is known as parallelogram law of addition. Parallelogram law of addition. Parallelogram law of addition. And this concept, one diagonal represent addition, another diagonal represent difference, is known as parallelogram law of addition. ಅರ್ಥ ಆಯ್ತಾ? ಒಂದೇ parallelogram ಅಲ್ಲಿ ಎರಡು diagonal ಇದೆ, ಎರಡು diagonal represent different thing. One is sum, another one is difference. So please remember this. Okay, so in a parallelogram, suppose if I I'll write here one small diagram. Observe carefully. So if this is A, this is B. Observe carefully. One diagonal represent its sum. Okay, another diagonal represent its difference. One diagonal represents sum, another diagonal represent its difference. One thing you observe carefully here. Out of two diagonal, one will be the largest, another one is the smallest, or the one is a bigger one is a smaller one. Now is it always that the sum of two vector which is represented the two sides of a parallelogram is always largest? For this diagram, agree. The largest side is the sum of two vectors. So the smallest diagonal will be the difference of two vectors. But if the parallelogram is like this, if the parallelogram like this, okay, this is A, this is B, and then this is A, this is B, then what does this represent? This represent is always, the sum only, and this represent difference. So don't generalize any result here. Okay, that sum should be always the largest diagonal and difference is always the smallest diagonal. No need like that. Okay, you just remember two diagonals are A plus B and A minus B. The largest term, smallest decide ಮಾಡೋದು after finding its magnitude, not before that. You A plus B, suppose question is find the largest diagonal of a triangle. NCERT book alilla, but CET alla keltare find the largest diagonal of a parallelogram when two adjacent sides are given. What is your work? Don't decide directly that A plus B is largest, A minus B is largest. See, you can observe here which is the largest, A minus B, here which is the largest, A plus B. Both of them are possible. So what you should do after finding A plus B and A minus B, find its magnitude, then decide which is largest. Artha aita? So direct A plus B and largest and decide ಮಾಡಬೇಡಿ, it is not always true. So find out A plus B and A minus B and their magnitudes. Magnitude will decide, not the diagram, not any result. Clear? So ನೆನಪಲ್ಲಿ ಇದು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ whenever they ask largest diagonal, you find out sum and difference and its magnitude, then decide. Clear? Very good. So first algebra of vector is over, that is additions of two vectors. Additions of two vector, as well as I explained in this parallelogram law of addition, difference of two vector, that is B A minus B also. Okay, so now some properties are there, okay, related to additions of two vectors. In textbook it is proved, but I am not going to prove these results. If you are interested, just go through which is there in the NCERT textbook. ಯಾಕೆ ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಇಷ್ಟಂಗೆ ಅದು ಎಕ್ಸಾಮ್ ಯಾವ ಎಕ್ಸಾಮ್ ಅಲ್ಲೂ ಕೇಳಿಲ್ಲ. ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಡೆಫಿನೆಟ್ಲಿ ನಾಟ್ required, and in entrance exam proofs are not required. But ನಿಮ್ಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಇದ್ರೆ ನಿಮ್ಗೆ okay, you just observe the proof which is given in NCERT textbook. ನಾನು ಪ್ರೂವ್ ಮಾಡ್ತಿಲ್ಲ, I am just giving the statement. Okay, so which are the properties? You know all these properties actually. Commutative property, associative property, identity property, ನೆನಪಿದೆ ಅಲ್ವಾ? ಅದನ್ನೇ ಮತ್ತೊಮ್ಮೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿರೋದು. Remember, vector addition is commutative. Vector addition is commutative. ಅಂದ್ರೆ ಏನು? A plus B is equal to B plus A. You can use the parallelogram law of addition to prove this. Remember that. ನಾನು already ಒಂದ್ಸಲ hint ಕೊಟ್ಟಿದ್ದೇನೆ, recall ಮಾಡಿ. If you want to prove, refer textbook, proof is given in that. I'm not going to do this. Next one is associative property. A plus B plus C is equal to A plus B plus C. You know this pattern because we studied one full chapter related to this. So ಇದನ್ನು prove ಮಾಡಿದ್ದಾರೆ textbook ಅಲ್ಲಿ, interest ಇದ್ದರು observe ಮಾಡಿ. So associative property. Even you know identity property. A plus E is equal to E, A star E is equal to E star A is equal to A implies E is called identity element. Adhe tara we know that whenever you add a zero vector to any vector, okay, you will get that vector itself. So zero vector is known as additive identity of a vector. Zero vector is known as additive identity of a vector A, because vector A plus 0 equal to 0 plus vector A is equal to vector A. ಇದೆಲ್ಲ ಪ್ರಾಪರ್ಟಿ ನೀವು ಬೈನರಿ ಆಪರೇಷನ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ರಿ. ಓನ್ಲಿ ದ ಆಪರೇಟರ್ ಇಸ್ addition, okay, of vectors, additions of vectors. So remember that. So it is commutative, it is associative, as well as it is additive, or it satisfies identity property. Clear? ಅರ್ಥ ಆಯ್ತಾ? Addition of two vector and its properties. Okay, next, very important, one more algebra of vector, which is scalar multiplication of a vector. This is also very important, and this is known as scalar multiplication of a vector. Scalar andre godide, okay, multiplication andre godide. So you just merge two concepts. So you are multiplying a real number to a vector. Scalar multiplication andre one real number na vector ge multiply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂತ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. Okay, observe carefully. Yeah, let k be a scalar. Scalar ಅಂದ್ರೆ no real number. Here scalar is nothing but a real number. Okay, a be a vector. So consider a one scalar and a vector. Then scalar multiplication of a vector. Then scalar multiplication of a vector a is a vector of a vector a is a again vector. Observe ಮಾಡಿದ್ದು, when you multiply a scalar to a vector, the resultant is again a vector. ನೆನಪಿಲ್ಲಿ, when you multiply a real number to a vector, the resultant is again a vector. Vector ಅಂತ ಹೇಳಿದ್ಮೇಲೆ you should describe or you should explain its two quantities. ಯಾವ್ದೆಲ್ಲ ಹೇಳಿ? magnitude and direction. Now I will explain that. ನೀವು ಸ್ಕೇಲರ್ ಅಂತ ಹೇಳಿದ್ಮೇಲೆ ಮುಗೀತು, ಜಸ್ಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಹೇಳ್ಬಿಟ್ರೆ ಮುಗೀತು, ಅದಕ್ಕೆ ಮುಂದೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬೇಕಂತಿಲ್ಲ. ಬಟ್ ವೆಕ್ಟರ್ ಅಂತ ಹೇಳಿದ್ಮೇಲೆ ಅದ್ರದ್ದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಅಂತ ಹೇಳಬೇಕು, and also you should explain how to find out its direction. Observe carefully. Scalar multiplication of a vector is a vector, and how to represent that? K into a. K into a represents scalar multiplication of a vector a with the scalar k. Scalar multiplication of a vector a with the scalar k is represented as k into vector e. Okay, then what is the magnitude of that? The magnitude of that vector is k into magnitude of vector a. If you want to find out the magnitude of a scalar multiplication vector, you just keep the k outside, find out the magnitude of vector a, then multiply k. That's it. I'll explain with the example, don't worry. So to find out a magnitude of a vector, you just multiply k to the magnitude of vector a. ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಗೊತ್ತಾಯ್ತಲ್ಲ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್? ಹಾ, ನೆಕ್ಸ್ಟ್ ಯು ಶುಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ಸ್ ಡೈರೆಕ್ಷನ್. ಡೈರೆಕ್ಷನ್ ಗೊತ್ತಿರಬೇಕು, ಹೇಗೆ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂತ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, ಡೈರೆಕ್ಷನ್ ಈಸ್ ಸೇಮ್ ಆಸ್ ದಾಟ್ ಆಫ್ ವೆಕ್ಟರ್ ಎ ಇಫ್ ಕೆ ಈಸ್ ಪಾಸಿಟಿವ್. If k is positive, if you multiply a positive real number to a vector a, there is no change in the direction of vector a. If you multiply a positive real number to a vector a, then definitely there is no change in the direction of k into vector a. But if you multiply the negative number, if you multiply a negative real number to a vector a, then the direction of k into a is opposite to that of vector a. The direction of k into vector a is opposite to that of vector a if k is negative. If k is positive, the direction is same as that of vector a. Magnitude ಗೊತ್ತಾಯ್ತಲ್ವಾ? Magnitude of vector a is okay, k into magnitude of vector a, and direction is same when k is positive, direction is opposite when k is negative. Clear? I'll explain with the one diagram. Observe this carefully. I'll consider a vector in the form of diagram. I'll explain, not by consider some vector. So let me consider a vector a with the magnitude is 3, direction is like this, a to b. Yeah, now I will multiply k, which is equal to 3, to this vector a. So ಏನಾಗುತ್ತೆ ಹೇಳಿ, what is a k into vector a then? K ಅಂದ್ರೆ ಏನಿಲ್ಲಿ 3 into vector a. Definitely there will be increase in magnitude because you are multiplying some number. ಅದು ಪಾಸಿಟಿವ್ ಆಗಿರಲಿ ನೆಗೆಟಿವ್ ಆಗಿರಲಿ, definitely magnitude will increase. ಎಷ್ಟು increase ಆಗುತ್ತೆ? Now the magnitude of vector k into a must be 3 into 3, 9 units. Magnitude of vector k into a is 3 into 3. Why 3 into 3? 3 is the scalar and another 3 will be the magnitude of vector a. So it is 9 units. So magnitude decide to 3 times of the given vector. 3 times, okay, of the vector a. Now what is the direction? Since k is positive, direction is same as that of vector a. Direction is like this. This is the direction of the 3 into vector a. ಅದೇ ನೀವು k ಅನ್ನ -3 ಮಾಡಿದ್ರೆ, if you take scalar as a -3, the magnitude will remain same. magnitude ಅಲ್ಲಿ ಏನೂ ಚೇಂಜ್ ಇರೋದಿಲ್ಲ, magnitude is same because 3 into magnitude of vector a is 9 only, but direction is opposite to that of a. direction is opposite to that of A. Andre this is minus 3 into vector A. Magnitude is same, only direction will change. How direction will change? Directly opposite to the given vector. So k positive the direction same agate, k negative the direction difference agate, but magnitude will be same procedure, 3 into k into that of vector A. Magnitude alli ಏನು difference ಬರಲ್ಲ, okay, but direction will change agate. ಅರ್ಥ ಆಯ್ತಾ ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್? ಸೊ ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು, because this will be used so many times in a problem. So whenever you multiply a real number to a vector, the magnitude is that real number into magnitude of vector A. Direction is depending on the sign of the real number. Correct? Yes. Now I'll explain one very important note. Okay, this is based on this concept we are going to solve so many problems in this chapter called vector. So listen carefully, understand this concept properly. Yes, unit vector along the direction of vector A. Unit vector along the direction of vector A. Unit vector andrenu? A vector with the magnitude 1. Now you have to obtain a unit vector in the direction of this vector. Magnitude 1 ಆಗಿರಬೇಕು, compulsory magnitude of the vector should be 1. If the given vector is vector A with some unit, let it be 3 or 4 units, then magnitude of the new vector which I am going to obtain now, it should be 1, because it is a unit vector. Unit vector in the direction of vector A is denoted as A cap. Is denoted as A cap, and A cap is magnitude of vector A by its magnitude. Sorry, vector A cap is equal to vector A by its magnitude. Vector A cap is equal to vector A by its magnitude. Why it must be like this? Okay, observe carefully. I'll explain why it must be like this. Yeah, you know that magnitude of any vector is always greater than 0, alva? Greater than or equal to 0. Magnitude of a vector cannot be negative. It should be always positive. Length, magnitude andre no length. Minus 2 centimeter length ಅಂತ ಹೇಳಿಕ್ಕೆ ಆಗುತ್ತಾ? ಇಲ್ಲ, ನೆಗೆಟಿವ್ ಆಗೋ ಚಾನ್ಸ್ ಇಲ್ಲ. ಸೊ ಲೆಂತ್ ಕೆನಾಟ್ ಬಿ ನೆಗೆಟಿವ್, ಸೊ magnitude of vector A should be positive. Okay, as well as magnitude of vector A is a real number, alva? It should be always a real number, scalar. Okay, it is a scalar always. Observe carefully now. Which one? This formula, vector A cap by magnitude of, okay, scalar. What is k here? Our k is 1 by determinant of A, sorry, 1 by magnitude of vector A. Again this is not equal to 0, as well as this is also belongs to R. So it is a scalar multiplication of a vector. Okay, so we have to check the direction first. Since this k is always positive, according to this concept, the direction of vector A, alva, is along vector A. Why? What is the reason? K is always positive. K is positive, alva? Always positive. K is always positive. So direction of vector A is along vector A. Ishta artha aita? As well as observe this magnitude concept. The magnitude of vector A cap, okay, is equal to magnitude of k into vector A. Andre k is magnitude adu modulus k ಹೊರಗೆ ಬರುತ್ತೆ, okay, into magnitude of vector A. But what is the k? K is nothing but 1 by magnitude of vector A into magnitude of vector A. So here to cancel out, what is remaining? 1. What is represent? Unit vector. So this represent a unit vector. This represent a unit vector along the direction of vector A. This represent a unit vector along the direction of vector A. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ಸೊ ವೆಕ್ಟರ್ A cap represent a unit vector along the direction of vector A. Along the direction because k is positive, and it is unit vector because when you take the magnitude of vector A cap, you will get magnitude of vector A by magnitude of vector A. It cancel, it gives 1 unit. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ this is a very important concept. Please remember, very important concept. So many different types of problems we are going to solve in this chapter called vector. So remember, unit vector in the direction of vector A is denoted by A cap, and it is nothing but vector A by its magnitude. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ we completed today additions of vector. ಅದ್ರಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬಂದಿದ್ದು, ಓಕೆ, parallelogram law of addition, triangular law of addition, scalar multiplication of a vector, as well as unit vector in the direction of vector A. In next class I am going to explain position vector and representation of a vector in 2-dimensional and 3-dimensional. ಅರ್ಥ ಆಯ್ತಾ ಇವತ್ತು ಮಾಡಿದ್ದು? ವೆರಿ ಗುಡ್, ಥ್ಯಾಂಕ್ ಯು.